Okay, this is Module 5, Lesson 6. And our goal today is that I will be able to decompose fractions using area models to show equivalence. And equivalence just means that they're the same, they're equal. So let's take a look at the problem set. It's on page 24 if you have your math book. The directions are pretty long, but I think we're going to kind of cut right to the chase. We're going to kind of take some of this stuff in the middle and not do it as much. Let's look at the directions. It says each rectangle represents 1. Draw horizontal lines to decompose each rectangle into fractional units as indicated. Use the model to give the shaded area as a sum and as a product of unit fractions. Use parentheses to show the relationship between the number sentences. The first one has been partially done for you. We're going to skip this part. Which means we're basically just going to skip this stuff here. But we are going to do this part and this part. Okay? So our example problem gives us an area model, and it says we have to break it into sixths. And it already gives us our 2/3 to start, the two horizontal fractions are 2/3 because this is broken up into thirds. And then they've broken it up halfway to make sixths. So you have 2 rows, and that makes sixth. So in other words, each of these little areas is 1/6 of the whole area model. Therefore, once we decompose 2/3 to make sixths, we find out we have 1, 2, 3, 4 sixths. So 2/3 is the same as 4/6. We can fill in our 6 right there. And then as a multiplication sentence, we know that 2/3 equals 4 times 1/6, which then equals 4/6. Let's do another practice problem. This one has us decomposing our fraction into tenths. And we know our initial fraction, given this area model, is 1, 2, 3, 4, 5. So it's fifths. And the shaded area represents 1, 2 fifths. Okay, and I got to make that into tenths. I got to figure out what's the equivalent fraction in tenths. Well, if I divide my fifths in half, then I have 2 rows. And each of those is going to be a tenth. Let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, 10 spaces. So each of these is then 1/10. And I could fill all these guys in if I wanted to. So altogether, that's 10 tenths. The shaded area, which was our 2 fifths, is 1, 2, 3, 4 tenths. Therefore, 2 fifths is the same as 4 tenths. And then we'll do our multiplication sentence. 2 fifths equals 4 times 1/10, which equals 4 tenths. Okay, moving on. I'm going to skip this one and let you guys work on that on your own. The next section has us doing basically the same thing. We have to draw our own area model now to show the equivalence using the decomposition. So what we're going to do is we're going to draw our box. I recommend drawing a nice big box. We're going to show our initial fraction, which is 3 fifths. That means I need to draw 4 vertical lines to show fifths. 1, 2, 3, 4, 5. And I'm going to shade in 3 of them to show 3 fifths. Okay. Now I got to show that that equals 6 tenths. I'm going to label this 3 fifths. I got to show that that equals 6 tenths. Well, if I have fifths, I know if I draw 2 rows, that means I will have double the amount of boxes, which means I'll have tenths. So therefore I have 1/10, 2 tenths, 3 tenths, 4, 5, 6, 7, 8, 9, 10. And then the shaded area is 1, 2, 3, 4, 5, 6 tenths. So 3/5 is the same as 6 tenths. And we'll write it as a equivalence. 3/5 equals 6 tenths. And as a multiplication sentence, 3/5 equals 6 times 1/10, which equals 6 tenths. By the way, the next lesson and the next couple lessons, we're going to get to a shortcut to figure out these equivalent fractions, which is basically you're multiplying here by 2 over 2. So 3 times 2 is 6, 5 times 2 is 10. So that's how you get to your 6 tenths, right? Similarly here on this problem, you're multiplying times 2 over 2. 4 times, or 2 times 2 is 4, 5 times 2 is 10. Okay? And this last problem you just have to read carefully. It says, step 1, draw an area model for a fraction with units of thirds, fourths, or fifths, so choose one of those. Shade in more than one fractional unit. So I could choose, for example, 2/3. I could choose, for example, 2/4. I could choose, for example, 2 or 3/5. More than one fractional unit. In other words, I should not be showing 1/3 or 1/4 or 1/5. Partition the area model again to find an equivalent fraction. Write the equivalent fractions as a number sentence, okay? So here, though, we're just going to say as a multiplication sentence. Okay? So as an example on this one, I could go, let's go thirds. I'm going to say thirds. I'm going to say 2/3 equals something. So I'm going to start with my thirds. Okay, there's my 2/3. And then I'm going to decompose it to show an equal unit. Well, let's decompose it into, let's say, twelfths. Well, to decompose it into twelfths, that's ninths and twelfths. Now, ideally, those boxes should be equal, but you get the picture. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each of those is twelfths. So I could label each of these 1/12, 1/12, 1/12, 1/12, 1/12, all the way down. So I know how much each box is worth. And I can label my 2/3 up here. And then to figure out what the equivalence is I can simply just count up my shaded 1/12 boxes. Well, I have 1, 2, 3, 4, 5, 6, 7, 8. 8/12. So 2/3 is the same as 8/12. Okay, and then as a multiplication sentence, I could simply say 2/3 equals 8 times 1/12 or 8/12, and then the shortcut, as I was saying before, is 2/3 times 4 over 4 equals 8/12. Okay. And that's it.